Hello, geometry students. So the focus for today's lesson, as it says on the top of the page here, is about angles of elevation and depression. Now, these are, again, it's still going to involve trigonometry, your sine, cosine, and tangent, but we're going to focus on the word problem aspect of it. So let's go over some basic definitions first. So as it says in the top here, so an angle of elevation is the angle formed by the horizontal line and an observer's line of sight to an object above the horizontal line. So if you think about you're a person on the sailboat, so here you are out there on your sailboat. The line of sight from the sailboat up here up to the lighthouse, again, that's your line of sight. Okay, your line straight across here would be your horizontal. So again, an angle of elevation is the angle formed with the horizontal and observer's line of sight, and again, it's above the line of sight. So this angle here would be an angle of elevation. I like to think of it as going up, elevating, that's your angle of elevation. In contrast over here, if you are the lighthouse keeper above here, and again, you see the plane, so again, this is your line of sight, and this would be your horizontal, again, from this perspective. So this angle here would again be an angle of elevation. Now, in contrast, the angle of depression is an angle formed again by the horizontal line and an observer's line of sight, but this time it's below the horizontal. So if you are the lighthouse keeper and you look down and you see the sailboat, so again, it's below the horizontal, so this angle here would be your angle of depression. You're thinking down, so angle of depression. If you are in the airplane up here and you look out and you see the lighthouse, this angle here would again be the angle of depression. You're looking down, that's the angle of depression. Now, if you keep in mind, your angle of depression and your angle of elevation are going to be congruent within the same picture. If you think about it in terms of those two highlighted lines here, those are alternate interior angles, and your horizontals are going to be parallel. So your alternate interior angles are always congruent. So what we're going to do next is we're going to take a look at some scenarios, come up with a diagram, and then talk about how to solve the problem. So I'm going to zoom in a little bit to make it easier to see. So in the first case, the story, it says a person in a tower sights a person on the ground. The angle of depression is 40 degrees and the tower is 45 feet tall. How far is the person from the base of the tower? So we're going to draw a picture. So here's my tower. Okay, so a person in a tower sights a person on the ground. So here's my person on the ground. So sights a person on the ground. So again, my right triangle is going to be here. If we need to highlight it, we can. So again, this is the right triangle in the picture. Now again, it says the angle of depression is 40 degrees. So angle of depression is formed with the horizontal and the line of sight. Again, that angle is 40 degrees. It says the tower is 45 feet tall. So here's my tower here. That is 45 feet. We want to figure out how far is the person from the base of the tower. So this bottom length here, we're going to call that X. Now remember that I just said, when you've got horizontals, your angle of depression and your angle of elevation are congruent. If you look at it in blue here, you see my zigzag, my Z, those are your alternate interior angles. So that tells you that this angle here of elevation is 40 degrees as well. So remember, when we solve these problems before, we would focus first on the acute angle that we know. That is this 40-degree angle. And if we identify the sides, opposite would be the 45, that's the side across from it, and adjacent is the one next to it that's not the hypotenuse. So if we are using opposite and adjacent, that's the TOA part of SOHCAHTOA. So that means we're doing tangent. So to solve it, we're going to say the tangent of my angle, which is 40 degrees. And again, tangent's opposite over adjacent, so we're going to put 45 over x. And now we're going to grab our calculator. So the tangent of 40 as a decimal, 4 places after the decimal, would be 0.8391. And again, that equals 45 over x. So when we solve them, remember, when we did these before, we're going to put the decimal over 1 and do cross products. So we're going to have 0.8391x equals 1 times 45 is 45. So to continue solving, we're now going to divide both sides by 0.8391. So if I grab my calculator and take 45 divided by 0.8391, I get an answer, and let's round to the nearest foot in this problem. So if it's 53.6, we're going to round this to 54 feet. So what's different about these problems is that you're going to have to draw your own picture. That's going to give you the problem in terms of a story over word problem. So you're going to draw your picture, and then you're going to come up with the appropriate trig ratio to solve. So I have 4 of these to go through with you. And the second one, it says a person is standing 4.2 meters from the base of a tree. The angle of elevation to the top of the tree is 38 degrees. Find the height of the tree. So if I'm going to draw a picture, so here's my tree. So a person over here is standing, again, it says 4.2 meters from the base of the tree. The angle of elevation to the top of the tree, so that's going to be looking up here. This angle is 38 degrees. We are trying to find the height of the tree. That would be this length x here. So again, if I need to, I'm going to highlight it for you. This is my right triangle. Okay, so again, what we always used to do before is we would circle the acute angle that we know we're trying to find. In this case, that's 38 degrees. The x is your opposite, and the 4.2 meters is your adjacent. So again, if you're doing opposite and adjacent, you're doing the TOA part. So we're going to stay tangent. So the tangent of my angle, which is 38 degrees, that equals the opposite, which is x, over the adjacent, which is 4.2. So again, I'm going to grab my calculator. So the tangent of 38, 4 places after the decimal, is 0.7813. So just like before, we're going to put the decimal over 1 and do cross products. So 1 times x is x, and 0.7813 times 4.2. And since this one already had a tenth in it, let's keep the 10th spot in this one. So if it's if you can see that there, 3.28. So we're going to round that to 3.3, and then my unit would be meters. Now, on more problems than not, on a side note, you probably end up using tangent. Just as a side note, that happens more than the other ones in these word problems. Okay, so on the next problem, it says find to the nearest degree the angle of elevation of the sun when a vertical post 15 feet high casts a shadow which is 20 feet long. So here is my post. So again, I've got the sun up here casting a shadow down. So my shadow, think about shadows. Shadows are on the ground. And it says the vertical post is 15 feet high, so this would be 15 feet. The shadow, which is on the ground, is 20 feet. And I want to find the angle of elevation. So again, going up, this is the angle theta or x, whatever you want to call it. So again, with respect to this angle, 15 would be opposite, 20 would be adjacent. So if I'm dealing with opposite and adjacent, we're probably talking about, again, the TOA or the tangent part. So we're going to say the tangent of theta equals opposite, which is 15, over adjacent, which is 20. So when we did these problems before, the next step would be to write 15 over 20 as a decimal. So 15 divided by 20 is 0.75. So now, to find your angle, you're going to do the inverse tangent of 0.75. And to the nearest degree, we're going, and it says to the nearest degree, so we're going to round, and it's going to be about 37 degrees. My calculator says it's 36.8, so again, I'm going to round that up to 37. Okay, we've got one more problem to take a look at here. It says an airplane which had taken off from an airport traveled a ground distance, a horizontal of 3,660 feet. What is the angle of elevation from the point of takeoff to the point when the plane has traveled 4,150 feet through the air? So again, here's my airplane up in the sky here. So again, I want to find the angle of elevation from the point of takeoff. So the plane is going to take off into the sky. So the angle of elevation would be the angle formed with the ground here. That's what I'm trying to find, theta. And again, it says it traveled a ground distance, that's your horizontal down here, of 3,660 feet. And again, I am asked to, or it also tells me that the plane traveled 4,150 feet through the air. So that would be this length here. That's through the air. So this one's a little bit different in terms of it's not tangent. So again, the acute angle that I want to find is theta. And this segment of 3,660 feet would be my adjacent. The 4,150 feet would be my hypotenuse. So if I'm using adjacent and hypotenuse, I should be using cosine. So on this one, we're going to say the cosine of theta equals adjacent, which is 3,060, over hypotenuse, which is 4,150. So again, the next step is I'm going to take that fraction and change it to a decimal. So if I do that, and I want to keep 4 places after the decimal, we're going to have 0.8819. So to find my angle, I'm going to do the inverse cosine of 0.8819. And it doesn't say, oh, it does say round to the nearest degree. So I get, it's 28.1, so we're going to round that to 28 degrees. So today, again, the only difference is we're starting off with a word problem, a story. We're going to draw our own picture. You do not have to be artistic. You need to at least get the right triangle. And then we're going to use our appropriate trig ratio to solve the problem. If you have any questions, as usual, please let me know.